Hello friends, welcome to engineering tutorial. So far we have discussed questions related to equations of motion related to one-dimensional motion of an object or a body, motion in a straight line. So basically in the previous questions it was all about numerical analysis, applying equations of motion, handling the various kinds of situation. So the next series of questions we'll be doing graphical analysis. Okay, so basically different types of graphs will be given, be it displacement time graphs, velocity time graphs, and we have to interpret that, or we have to draw different types of graphs from the information given. Okay, two situations: either numerical data will be given, we have to draw the displacement and velocity time graphs or whatever nature of graphs it is asked, or graphs will be given, from that we have to determine certain values of certain parameters. Okay, it will be graphical analysis of one-dimensional motion or motion in a straight line. So this is the first question. So here it is given that the position time graph for a body in one-dimensional motion, that is along a straight line, it is shown here. It is a position time graph, position in y-axis, time in x-axis. From this we have to calculate first the initial velocity from 0 to 10 second duration, initial acceleration for the same, that is from 0 to 10 second, time for which the body is at rest, time for which the body is moving away from origin and towards origin. So it is a very simple question related to interpretation of graphs. So here first the initial velocity in the 0 to 10 second duration. So first let us copy this graph here. Okay, here we have copied it. Now from 0 to 10 seconds, here at the end of 10 seconds, in this entire duration of 10 seconds, when t was 0, the position was equal to 0. Okay, when t is equal to 10, the position is equal to 20 meters. Okay, so here velocity is simply final position, initial position, final time minus initial time, which is equal to 20 minus 0 by final time 10 minus 0, which is 2 meters per second. Okay, constant uniform velocity 2 meter per second for this entire 0 to 10 second duration. This is the velocity in the 0 to 10 second phase. Now in the same 0 to 10 second phase, as it is moving with constant uniform velocity, it means change in velocity is nothing, 0. Okay, so as change in velocity is 0, it is constant uniform velocity, so acceleration will be how much? 0 meter per second square, because it is moving with uniform velocity in the 0 to 10 second phase. Okay, uniform velocity in 0 to 10 second phase. Then it has been asked to find the time for which the body is at rest. Now if you look closely, from A to B, the position of the object is not changing at all. It is constant, flat line position. It means it is at the same position, that is 20 meter position. from 10 seconds to 15 seconds. So for this entire duration, from 10 seconds to 15 seconds, a total of 15 minus 10 equals to 5 seconds, the object is at rest. Okay. Then it has been asked to find the time for which the body is moving away from origin and towards origin. Okay. Now, here, please focus on the time duration from 0 to 10 seconds. Position is moving upwards of 0. Okay, 0 to 10, 10 to 20, from 0 to A. So it is moving away from origin. Again, focus on this 15 to 20. Values are increasing from 20 to 30 to 40 and then to 50 finally in C. Okay, from 20 to 50. So the curves OA from 0 second to 10 second and BC from 15 seconds to 20 seconds. It is moving away from origin. Because of the position values, it is going upwards. Okay, then towards origin. Now, focus on 20 to 30 in this time duration. The position value x is dropping down. First at C it is 50, then it drops down to 40, 30, then finally 20, 10, and then finally at 30 it is dropping down to 0. It has reached 0. Okay, 0, back to where it started. So CD curve from 20 to 30 second, it is moving towards origin. That is a total of how much? 10 seconds. Here a total of 10 seconds in OA, it is moving away from origin. Here a duration of 5 seconds from 15 to 20, again it is moving away from origin. Okay, so a very simple question related to interpretation of position time graph to determine the various parameters. Again, if we want to determine the velocity in the BC phase, suppose we want, it has not been asked, but let us say we want to determine the velocity in the BC phase. So here the initial time, this is the initial time where our reading started, Ti, and here it is TF. Ti is 15 seconds, TF is 20 seconds. This is initial position Xi, which is 20, and final position XF, which is equal to 50 meters. This is 20 meters. Here it is Ti is 15 seconds, TF is 20 seconds. So again, velocity in the BC phase, okay, the BC curve, that is equal to final position minus initial position by final time minus initial time. Final position is how much? 50, initial is 20, 50 minus 20. Final time is how much? 20 minus 15 here. Initial time is 15 minus 15, which is equal to 50 minus 20 is 30, 20 minus 15 is 5, 30 meter by 5 second, that is equal to how much? 6 meters per second. So in this 15 to 20 second interval, the velocity in the BC phase is 6 meters per second. Okay, that's why it reached 50 here. Okay, so a very simple question related to interpretation of position time graph to determine the various parameters. Okay. So here is another question on graphical analysis of one-dimensional motion. So it is given that a car accelerates from rest at a constant rate alpha for some period of time. After that, it decelerates at a constant rate beta and finally comes to rest. If the total time elapsed during this whole acceleration and deceleration, the total time elapsed is t, calculate the maximum velocity acquired by the car and express the whole situation graphically. So here we will be using a velocity time graph to express the whole situation. Let us say we take the y-axis, which is the velocity axis, the x-axis, which is the time axis. Okay, this is velocity. So it is given a car accelerates. So here we'll be taking uniform acceleration. So it starts from rest, accelerates, we'll be using a different, let's say this. It accelerates up to a certain point where it attains a certain maximum velocity, and from here it starts decelerating. Okay, let's say it starts decelerating and finally coming to rest. This is the deceleration region, this is the acceleration region. Okay, this is the acceleration region. Okay, now let this angle be theta 1 and this angle be theta 2. Let this time from here to here it be t1. Okay, this whole period during which it undergoes acceleration, and this period during which it undergoes retardation, that is t2. Now the acceleration alpha is equal to the slope of this curve. Okay, let's also name it OAB, like this. The slope of the curve OA, which is tan theta 1. Okay, so let this be C. It is simply AC by OC. Okay, AC by OC, which is equal to Vmax by T1. Okay, this much. Now 1 by alpha will be equal to T1 by Vmax. There is no problem with that. Simply we are taking the reciprocal. Okay, this is, let's say, the first equation. Then let the slope, the retarding slope, okay, the retardation slope for AB curve, that is equal to beta. Here we are not taking the negative sign, here we are only concerned with the magnitude of retardation. Beta is tan theta 2, which is equal to AC by BC. Again, AC is equal to Vmax and BC or CB, whatever it is T2, Vmax by T2. 1 by beta will be equal to T2 by Vmax. Okay, this is, let's say, equation number 2. Now if we add equation 1 and equation 2, that is adding equations 1 and 2, we get 1 by alpha plus 1 by beta is equal to T1 by Vmax plus T2 by Vmax. Okay, so on the left hand side we have, that implies it is equal to alpha beta by beta plus alpha. On the RHS side we have Vmax T1 plus T2. Now we know that T1 plus T2 is the total time elapsed, which is given T. So we can write it as T by Vmax. Okay. Now Vmax by T will be equal to alpha beta by alpha plus beta. Okay. That implies Vmax is equal to alpha beta by alpha plus beta into T. This. Okay, so this is the maximum velocity acquired by the object during this whole acceleration and retardation process. And we have expressed it in terms of acceleration alpha, retardation beta, and the total time elapsed T. This is the expression for maximum velocity for this whole situation. Okay, so this is the whole thing. And we have deliberately we chose the velocity time graph because acceleration was involved. Acceleration is simply the slope of velocity time graph. We were asked to find the maximum velocity, so obviously velocity time graph is the appropriate choice of parameters for expressing the whole situation graphically. Okay,